Paul introduced the concept of Micropython functions in Lesson 61. He explained that breaking the functional blocks of our programs into separate Micropython functions made them easier to understand and support. Paul also explained variable scoping and the process of passing and returning variables. Our assignment was to collect a list of grades from the user. Grades could be entered in any order. We were to sort the grades in descending order and print the sorted list. We were also to calculate and print minimum grade, maximum grade, and average grade. Of course, we were expected to accomplish this with functions. We were also challenged to do all this, especially the sorting, without using publicly available or built-in routines. The bulk of this program is pretty straightforward. The sorting requirement took me back to my first programming classes many years ago. I thought I'd try to develop a bubble sorting algorithm to sort the grades. Those of you familiar with bubble sorting may want to use the chapter markers to skip ahead to the code. Bubble sorting may or may not be the most efficient sorting algorithm, but it is relatively easy to explain. The core of the bubble sorting routine is an algorithm which compares each element in the array with the next element, evaluating whether the two elements are in the required order or not. If the two elements are already in the right order, the algorithm moves on. If the two elements are not in the right order, the algorithm swaps the two entries, then moves on. Let's sort the following short array in descending order. Grades 65, 72, 71, 85, and 92. The algorithm starts by comparing 65 and 72. 65 and 72 are not in descending order, so we swap them. Next, we compare 65 and 71. 65 and 71 are not in descending order, so we swap them. Next, we compare 65 and 85, also not in descending order, so we swap them. Finally, we compare 65 and 92, also not in descending order, so we swap them. So after 4 passes through this 5-element array, we have moved the smallest element to the end of the array. This type of iteration through an array is the perfect use for a for loop. Pseudocode for this algorithm might look like that presented here. Notice that we limit the range of the loop to len grades -1. The algorithm is meant to compare adjacent pairs of elements. If we let the loop run all the way to len grades, the program would crash because there would be no next element for the comparison. So each time we execute our pseudocode, the next lowest element in grades will move into its appropriate place in the array. If we execute the pseudocode len grades -1 times, we will sort the entire array. Sounds like the perfect job for another for loop. The for I loop will run our original pseudocode len grades -1 times, and will sort the entire array in descending order. The downside of this approach is that we scan the array len grades -1 squared times, regardless of the initial order of the array. That could be a lot of wasted cycles if only 1 or 2 elements are out of order. We've seen that every time we complete the for-j loop, the next lowest element in grades will be in its appropriate place in the array, as we swap values as required. Regardless of where we are in the for I loop, if we complete the for-j loop without swapping any values, then all the array elements must already be in the correct order. Adding a swapped values variable to the if grades of j logic will keep track of our swapping activity. If we exit the for-j loop and swapped values is still false, then we must have gone through the entire array without swapping anything. The array is in order, and there's no need to continue the for I loop. We can break out of it early. Also, each time the for I loop completes, the next lowest value will have moved to its appropriate position in the array. Once those values are placed, there's nothing to be gained by working that far down in the array anymore. We can save some cycles by reducing the range of the 4j loop by subtracting I from the 4j loop range. So we've sorted the array and we've reduced wasted cycles with the use of the swap values variable and by reducing the range of the 4j loop as we go. The basic bubble sorting routine would take 16 cycles to sort a 5-element array. Adding our cycle saving logic reduces that to only 4 cycles. Let's see how this works in practice. This assignment contains 5 functions and a main routine. The enterGrades function creates an empty results array and a result variable set to 0. While result remains greater than or equal to 0, the function asks the user for a grade and appends their response to the results array. If the user enters a negative value, we exit the while loop and return the results array to the main program. The find high-low grades function sets initial values for max and min, then compares each member of the results array to max and min. If the current item is greater than max, max is reset to that value. If the current item is less than min, min is reset to that value. Once we've checked all the grades, min and max are returned to the main program. The find average grade function sets the total variable to an initial value of 0. It then adds each member of results to total. The function returns total divided by the number of entries in the results array to the main program. The for-I loop in the sortGrades function controls how many times the for-j loop runs. It may run len results minus 1 times. If the for-j loop ever finishes with swapped values still false, our grades are already in order, so we break out of the for-I loop early rather than wasting cycles. The for-j loop in the sortGrades function compares each element of the results array to the next element, checking to see if the next element is larger or not. If it is larger, the function swaps the elements with the help of a temp variable and sets the swapped values variable to true. This moves the larger values closer to the beginning of the array each time we go through the for-I loop. The for-j loop repeats len results minus 1 plus I times, or until swap values is false, at which point results is returned to the main program. The print report function formats our calculations and prints them in the shell. The main program is in the while true loop. It calls the enterGrades function, and if grades are entered, it calls the remaining functions and repeats. And here's how it looks. Here we can see the grades being entered in no particular order. A grade of -1 indicates the end of data entry, at which point the other functions are called. We can see that entering -1 with no other data simply re-triggers the enterGrades function. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.